Today we are going to discuss about support vector machine, which is also known as SVM model. Many students have asked me questions like, how do I know when to use SVM model and when to use a regression model? And there are many more models in machine learning. Here is my recommendation. If we have multiple independent variables and we can collectively use them to predict the dependent variable y, then a regression model is a good recommendation. On the other hand, let's say we have x and y variable and there is no way that you can predict y with x, but there is some relationship between them, then SVM model is the way to go. Let's understand this better with this Python code. So here I am working with Jupyter Notebook, and here on line 1 you can see I am importing numpy as np, and then I am doing matplotlib for plotting, and I am doing the inline magic, and the most important SKLearn is import SVM, and above all I am doing this SKLearn dataset import make blobs. This is very interesting thing that whenever I run short of data, sklearn itself has lot of sample data. We can use them to make meaningful data. So here if you notice, I am using this method make blob and I'm saying I want 30 sample records centered to, that means the output value is centered around two values, a and b, x and y, yes or no, anything of that kind. And there are two feature parameters, that means the x value, the input value are two of those, and the random state is used to make sure I am feeding in the same input seed values to generate the random numbers. So if I am able to do this, then I can create sample data, and this is a very sweet feature in sklearn that we can make lot of sample data. Now if you want to see how this data looks like, I can say capital X, and when I enter I can see these are the values. Because we have two features, it shows two values, and of course this will have 30 records or 30 samples, and by this we are able to generate those 30 samples. And now let me insert few more lines here, and if I say y, which is my dependent variable, and if I say it says zeros and 1, and there are only two possible value because it is centered around centers is equal to 2, that means there are only two possible output values. So that being said, I am able to create sample data based on the sample size, based on how many centers, features, and random state. Now moving on, let's try to put this code here. Yes. So here I'm creating a SVM model, and the kernel is linear. That means the model internally it's using a linear model for this. And then I am doing fit. Fit is a process where machine tries to learn with the sample data. So we are providing the sample of 30 data as input, and once I feed that as a input, with those 30 data the machine is learning. And if you notice here, I have capital X and small y. There is a reason behind that. The reason we have capital X, because it is a multi-dimensional array, and small y because it's a one-dimensional array, and we use capital X and small y to specify that X is a input which has multiple features and y is a output which has only one value for every point. Now let's do a scatter plot with the features, and here if you notice I do scatter plot with two input x colon comma 0 and x colon comma 1. So what does it mean? First colon means all possible rows or all the rows, and the 0 refers to the first column, and x colon comma 1 that means all rows and column number 1, which is actually second. And this s equal to 25 specifies the size you want for the scatter plot, and the remaining thing c map and c equal to y, we are using it for the color. And if I run this, let's see how it looks, and then we'll come back to the remaining logic. So now here if you see, I get 30 points because we started the data with 30 points here, right? Sample size 30. So I have 30 points. They are centered around 2. That's the reason we have light blue on the left and the brown color on the right. And it shows all the 30 points, and we are able to have a scattered plot with that. And what does this mean and how we can explain this better? Now imagine a 5-year-old comes to you and says, how do I identify a cat and a dog? So then I would say we should not explain SVM model to the 5-year-old. Instead, what we can do is we can explain the concept behind SVM model. What is that? A dog has longer snout. On the other hand, a cat has sharp ears. So if you watch, most of the cats have sharp ears and the dogs would have a longer snout. Well, maybe we can use this concept to identify a dog and a cat. Of course, there are many other features, many other things, or many other parameters we can use to identify, but I would say these two are the most simplest way which can be used in SVM model, or which would help a 5-year-old to identify to start with. So now let's go ahead, take 30 different like animals, maybe some of them dog and some of them cat, and let's go ahead and measure their snout and ear and make a data plot. And if you do the data plot, this is how it looks. On the x-axis I have the length of the snout, and the y-axis I have the geometry of the ear, which says if it is sharp, how it is. And if you notice, cats have sharp ears, so that's the reason on the y-axis they are higher, and the dogs have a longer snout, so that's the reason they are on the right hand side. So the blue color, the light blue color are the cats, and the brown color or the maroon are the dogs. So with this we are able to make data, and then we are able to do a scattered plot, and we are able to create a SVM model, and then we were able to train the model as well. So we train the model with line number 1 and 2, and scatter plot with line number 4, and then I also gave the labels which will help us identify what is in the x-axis and what is in the y-axis. Now let's say I go ahead and take two animals in random. They have some behavior in ears and the snout, and I'm going to identify whether it's a dog or a cat. So here is the first one, which value is -8 and 7, and this one the value is -1 and 5. I take these two as an input parameter, and I say predict, and I give x and test data as an input value. And once I give the test data as the input value to predict, it predicts that 0 and 1. That means one of them is a cat and one of them is a dog. Okay. Now coming to one of the important thing which I didn't tell you before is these data are made up data. Okay. Just for the sake of this video, So I would say take it easy why I have negative value for length of snout, and in terms of year how the measurement was done. I'm not going into those details. Okay, now let's move further and do some more analysis and try to understand how a SVM model works. So let's look under the hood and understand the concept of SVM model. Could you access the channel stream? Okay. Now, here if you notice, I've put in a big piece of code here. Let's understand this. Or let me first execute this and then we'll go ahead and explain the same logic. So when I run this piece of code, it creates a graph in the bottom, okay, and each of them have some meaning, and the solid line is called the hyperplane, and the two dotted lines are the margin lines, and each of this dot is a vector, and these two dot with circle and this blue dot with circle are called the support vector because they are supporting to create the margin. Okay, that's in short, but let's go in detail and look under the hood. Now here um, I am creating 200 sample records once again with make blobs centered with two because I have only two different animals, let's say cats and dogs, and random state is 7. And when I specify the random state, what's going to happen is if I rerun this code again, I'm going to produce the same output. This is a very important concept that if I change my state, then the data is going to change. So this is very helpful that when we are doing debugging and testing of data, each time we don't want the state to change and produce new result, and it's very difficult to test it. So I like to use this random state with one value by which I am able to retest the data with same values. Okay, then once I have done creating sample x and y values, I am able to once again do the learning of model, and I do the same linear model and I fit it. Okay, and here I am doing once again a scattered plot, and I am using the all the rows, first column, all the rows, second column, size is equal to 15, and the same color parameter, and I am doing a scattered plot. Okay, so once I have done that, the scatter plot is created, which would look something like that, right? So I have the scattered plot, but instead of 30 data point or sample point or vectors, I will have 200 vectors now because I have used the sample size as 200 here. Well, but I want to take this further and do some more analysis, and I want to explain how the SVM model works. And if you notice here, I have a function in the plot as GCA, which is get current access. What happens here is I'm able to get information on both x and y axis by using that method of plot, and I save that into an object called axis, and in that access object I'm able to get the x limit, and I'm able to get the y limit using the method get xlim and get ylim, and I store that in an object x limit and y limit. So basically what is a x limit and y limit? It has two values in that, 0 and 1. So it's an array with two values, and I say line space, create line space with those two values and split that into 13 parts and get me each of these values. So let's say if I split into multiple parts and Python is going to help you in splitting in pieces in windows or intervals and get you the values of each of them, and we store that in X unit and Y unit. Okay, so far so good that we are able to create X units and Y units which will have all the breakdown, and we store that into these two objects. Now, next step, what I am going to do is I am going to create a mesh. I'm going to cross this X and Y. So it's like a checkerboard or a graph sheet where all these X values and all those Y values are going to be combined, and we are going to put them together into a mesh grid. And NumPy has this method mesh grid. You input both X and Y units, and that will create grid for X and Y. But the challenge here is it's not coming in as a two-dimensional array. It comes as one-dimensional array with all the X and Y values. So to convert this to two-dimensional array, we have one more method in NumPy. It's vstack, and I use that, and I input both the X grid and Y grid as an input parameter, and I create a two-dimensional array. After I create this two-dimensional array, I have to transform it, because if I don't transform, then it's going to be horizontal, and I want to make it vertical, and that way it's in the format we need. Well, now we have the data. So what we can do is, next we have to find the z, which is a decision function, and then I reshape it in the way I need, and because later I'm going to use that to create my contour. Soon I'll explain you what is contour and how we are going to use that. And if you see that we create the z value, and in terms of contour, here I am going to create three lines. Okay, so we know what is this data point or the vectors. We have all this brown vectors, and we have this blue vectors, and our goal is to draw a line in between. The solid line is the hyperplane, and then we have two dotted lines, those are the margin. Now to draw that, what I am going to do is, and this line is a straight line, so it is a linear hyperplane, and I'm going to have a linear hyperplane between these two vector points, and that one is referred as level 0. Okay, so the solid one is level 0. So I feed this X grid, Y grid, okay, as a input parameter, and after I feed that with the Z and the color, and I say level equal to 0, and alpha is a transparency. The lower the alpha, it is lighter in color or it's transparent, and higher the alpha 1 or something, it's a solid black line. Okay, so now the lines, when I have dotted line, we say line style as dash dash, and when we have solid line, we say that single dash, and once again dotted line as dash dash. So if you notice, I'm able to draw these lines here with these values, where I say level equal to -1, 0, and +1, which represents whether it's a negative distance or positive distance or exactly center hyperplane. Okay, so give me a few minutes. I will go over all this code little more in detail so that we have more clarity here. Okay, so once we have drawn this hyperplane, which is the center line and the margin line, then the distance between the hyperplane and the margin is called the plus d and the minus d, which is the distance, positive and negative. And when you add this positive and negative distance, that makes the actual margin distance. So our model is better if the margin distance is higher, and our model is not strong enough when the margin is less, because we have more room for error then. So far we are able to put the dots, which are the vectors, draw the margin, draw the hyperplane, which is what it's separating. The reason we call that hyperplane is this is a two-dimensional demonstration, but it's possible to do the same thing in multi-dimensional space. Well, now let's see what is support vector. So we have various vectors. We find the two vector which is the closest to the hyperplane, and those in the brown one we have two of them with two circle around it, and in the blue we have one with a circle around it. So these are the support vector, and how can I develop a code for that? And to develop a code for that, I do a axis scattered plot, and here I am inputting both the values with support vector, and then I say size equal to 99, line width equal to 1, that is this around that circle width, and face color none because I want to maintain blue as blue and brown as brown, and I say edge color K. Fine. And then when I plot it, I see a graph like this. Okay. So what I'm going to do is I'm going to revisit the same thing in more detail. The reason I'm doing in multiple iteration is these are so much related with each other. I want to explain this concept and then open the hood and look more into it. So if you now look back to our prior code, here, if I increase my sample size from 30 to let's say 300, and if I enter and I say show me the x value, now I'm going to see lot more values, right? So instead of 300, I can also say 10, it will show me less. That's fine. Now let's say instead of saying centers as 2, I can say center as 3. And if I run this piece of code with sample size 10 and center as 3, so now if you see I have three possible values 0, 1 and 2. So that is how I am able to get different output combination. And if I draw this graph, see how it looks. It breaks into three different group. I have brown, orange and blue, right? So I can choose different combination. Now in terms of feature, there may be different parameters. When you say centers as 3, like maybe we are checking between dogs, cat, and monkey. Okay, three different species. And on the other hand, when I say features is equal to 2, instead of that I can say feature as 4. That means I'm going to see few features here. So one may be the length, one may be whether they bark, one may be whether they like milk. So there are different parameters, different things we can see to identify what kind of animals they are. Okay, and if my random state is 7 and I run this as many time as I want, I would get the same data. Now let's say from 7 I change it to 5 and I execute this. Now my input state for randomness has changed. So this output data is going to look different. So just look at this. The first number is ending with 429, and when I run it again, now it ends with 771. So basically my input X values have changed. So if you want to debug and test and analyze your data, keep the random state at the same level and run it as many times to debug your program. Well, so now we have like understood how this make blobs work and how this scattered plot and all that stuff. So with that, we were able to understand all this concept. And now coming back to this SVM model. So the reason I did this all over again is whenever I do a show of a scattered plot, it is going to reset it. So that's the reason I redid this logic here again instead of using the same one above. And then if you come down, let's focus on the last two line, which I feel is very important. Okay. So if you notice, we have three different levels: -1, 0, and +1. I can change these values to get different margins. So now let's say from -1 I change to -2, and now look at the graph how it looks. So it has moved in to the vector. Okay, so the support, it has crossed the support vector. This is the support vector, but the margin line is inside. Instead, I can also say here 0.5. Let's see how it looks. Now it is closer to the hyperplane and the support vector is far away, right? So these are the different ways we can analyze. And let's say I do my transparency alpha from 55, I make it 95, and now it is solid black. And now let's say from 95 I change it to 15, so it's very much transparent that it's so light we cannot even see the line. Okay, so these are the different ways we can make the contour. We can feed the values, change color, change the location of margin, transparency, and the line, the style. Okay, now moving on to let me put this in multiple lines so that you have better visibility. So let's say I put it this way, and now you can see the whole code where I say the X grid, Y grid, Z, color, level I can pass, alpha, and line styles. Okay, now let me put this as well in two lines. Okay, so here if you notice, I have my SVM model and I pass the support vector from 1 and 2, and I can say the size from 99 I make the size as 49, and I say the line width as, actually I should make line width, okay, let's make it 5. And when I run this piece of code, so now you see, because my line width is 5, it's a solid black circle, and the size is smaller, and that's the reason the dot is so small and it looks like that. So instead, what, let's do it differently. Let's make it back to 1, and now if you see, the size of the circle is smaller, and if I increase this to 99, it looks big. Okay. So I think with this we are done with SVM model. So we got to know when to use SVM model, and when we got to know like how to make data with make blobs, and then we saw the major concept, and then we were able to draw the hyperplane margin, and we were able to analyze all those things, and we also got to know what is positive distance, negative distance, and what is the final margin. So with this I'm done with the with SVM model, and I thank you for watching this video. And if you like what you're watching, I would request you to go ahead and subscribe this channel. Thank you. Bye now.